Welcome to all in Examrace. This is the statistical physics and we are here for concept of negative temperature. Here we will see the concept of negative temperature and related to the problems related to the concept of negative temperature. Also we will see the energy levels here, the two system levels, how we deal with these two systems level, how the entropy we can write this, and how the number of atoms in the different energy levels are varies, and how we will adjust these number of atoms and relate them with the entropy. Moving to the concept of negative temperatures, we must know what is the two-level energy system in the statistical physics. So just by the name, it is a two-level energy system. So for this, what we will see, we consider two level, that is one lower level, that is E1, and upper level, that is E2. And the energy difference between these two levels are E2 minus E1, obviously. For that, let's assume a temperature, thermal equilibrium temperature. Okay, the system is in thermal equilibrium. Okay, for that the temperature is T. Now we need to find the partition function for this system that is in the thermal equilibrium. And for the partition system, you know the formula, that Z is equals to e to the power, or you can write it like this, minus E by kT, where E is the energy of that system for that particular temperature T, and K is your Boltzmann constant. But here for the partition function, this system, that system has the two-level energy system we are talking about. So the partition function for the two-level system is going to be exponential of minus E1 over kT. Okay, this is for the first level, and for another level you can also write this as minus E2 by kT. Clear? So this is a two-level energy system partition function, and let this be the equation 1. Okay, so if I'm interested in finding the probability of occupancy of these states, means probability of occupancy of E1 state and E2 state. So if I want to find probability of occupancy, means how these energies can be occupied for, means this probability can be occupied for the particular states of these state. Here these states means your E1, E1 and E2. So if I say P1 is the probability for the occupancy of state E1, okay, probability for state E1, then how can I define this? It can be written as exponential of minus E1 by kT over partition function, that is the partition function of the state, or it is something like you can write this E1 by kT over whatever the total, that is my exponential of minus E1 by kT, and then plus exponential of minus E2 by kT, isn't it? Similarly, you can find the P2, where P2 is the probability of for the state E2 occupancy, and for this you can simply write it is going to be the exponential of minus of E2 by kT over Z, and which can be write as, you know, if I replace this Z value, I can write this as a exponential of minus E1 by kT plus exponential of minus E2 by kT. So this is your probability of the different occupancies of a state. Now we will just try to you can say modify this. Okay, so probability P1 can be written as, if I write the probability P1, it was minus E1 by kT over 1 plus, not 1 plus, is exponential of minus E1 by kT plus exponential of minus E2 by kT. And if you divide this with the E1 by kT, so it changes to 1 over 1 plus e to the power minus E2 minus E1 by kT. Okay, and for this let E2 minus E1 by K be theta, then my P1 changes to 1 plus 1 exponential of minus theta by T. Clear? Same way we can also write for the P2. So we have to divide with the E1 means exponential of E1 by KT for the P2 same. So it changes to e to the power minus E2 minus E1 by KT over 1 plus e to the power minus E1 minus, not actually E1, it's E2. E2 E1 by KT, which must be equals to e to the power or exponential of minus theta by T over 1 plus exponential of minus theta by T. Clear? These are the exponential probabilities that we find P1 and P2. Now we are interested that if T is equals to 0, what happens if T is equals to 0? Okay, so if T equals to 0, we can say your P1 was 1 over 1 plus e to the power minus theta by T, if you understand. So T upon 0 means it's going to be e to the power minus infinity. Okay, theta upon 0 is infinity, e to the power minus infinity is what? You can say 0, so 1 upon 1 remains. So if T is 0, we can say P1 is 1 and P2 is 0. So T is equals to 0 means we are talking about ground state. Okay, or we can say ground state system is there. Okay, what happen when T is very less than theta? Then your KT will be less than epsilon, or sorry, not epsilon, it's actually E is less than E. Then you can say P2 is negligible. Okay, or P2 can be negligible. And for this negligible, what happens? It begins with the increase when temperature is increased, like this. Okay, clear? So we must know what is P1, P2, how these are dependent with your conditions. Okay.